So for the rest of class, we're going to talk about temperature and its measurement. We'll talk about some of the conversions as well. So we should be able to do those pretty easily. In next class, we'll do there's an assignment associated with this. So temperature, quick recap, measures the kinetic energy, which is the energy associated with motion of the particles. So the scales that most people are familiar with are the Fahrenheit scale, which is not the worst scale in terms of science. It's to the coldest brine could be and the average body temperature. Now we know a little bit more about the average body temperature being 98.6, but when they came up with it, they assumed it to be 100. So Celsius is relative to the melting point and boiling point of water. That's a really good one. We use that a lot because, because that is based on something that is very reproducible. You can measure the temperature that water freezes or boils at relatively easily. So that scale was, and they said 0 is freezing, 100 is boiling. Boom, we got it. Kelvin is probably one that you guys haven't really used too much. No one's like, oh man, it's pretty warm outside. It's like 312 Kelvin. That's pretty warm. So you'll figure out how warm later. But it's directly related to the kinetic energy, and that's why it has no degrees. It has an absolute 0 where all molecular motion stops. So why we use science and Kelvin? Well, because they're based on things. Those are the SI units of chemistry. Fahrenheit is actually, in terms of communication, we're the only nation that really uses the Fahrenheit scale. So it's antiquated and no one really uses it except for us. But I get it. I have my Fahrenheit brain as well. I'm like, oh, I'm not like, oh, it's 27 degrees Celsius outside today. I'm like, oh, it's 80. Let's go out. Go outside. So here are some temperature conversions. If you guys are writing down, people, you guys can feel free to write down those formulas. Otherwise, they'll be posted up here. All right, so equivalent 0 Celsius is 237 Kelvin, which is 32 degrees Fahrenheit. 100 degrees Celsius is 373 Kelvin, which is 212 Fahrenheit. Just to give you guys some reference points. When TK is Kelvin temperature, TC is Celsius temperature, and TF is Fahrenheit temperature, these are your relationships down here. So these are the equations that relate them. And we're going to go over how to calculate some of those calculations and go over a couple examples. But first, let's talk about how heat and temperature are different things that are related, but they're different properties. The units of temperature, we talked about Celsius, Kelvin, Fahrenheit. The units of energy are joules, calories, BTU, which is a British thermal unit, which is a unit so antiquated the British got rid of it. Sorry, we don't like that. We use SI units, but they still use that in the United States because for some reason we like to keep our imperial units, even though the British have gotten rid of them a long time ago. All right. So just temperature is not energy side right here. So is temperature energy, guys? No, temperature and energy are different things. Different things, okay? So I like to think about it. Temperature directly is a kinetic measure of kinetic energy. So the higher the temperature, the faster the particles are moving on average. Lower the temperature, the slower they are moving on average. And a big idea, at the same temperature, particles have the same average kinetic energy. Okay. Here are countries that use the Fahrenheit scale and countries that use Celsius. Yes, we are the lone user of the Fahrenheit scale. That's it. I know, strange, huh? Oh, well, we use Fahrenheit. Fahrenheit, often considered the F word of chemistry. But it's actually not the worst scale. It's just not the one we use in science. And it's important in communication to be able to effectively communicate. So I always specify that's why we use Fahrenheit, Celsius, and Kelvin. All right. I like to think about units of heat, you know, it's asking a different thing. Like if I said, if we're going to the mall, and I want to know how long it takes to get there, and I say, oh, we're leaving at 2 o'clock. It really doesn't answer the question. It might be a true statement. However, the question's not being answered. So if I'm asking for how much energy did something gain, you said, well, it gained 12 degrees Celsius. That's not answering the question. If I'm asking for an energy, I'm asking for an amount of energy in joules, not a temperature change. So they are different things, and that's a big thing. So, all right. So we'll stop with the content. We'll go over some problems now.